0.35b. Okay, we're going to use A is equal to 0.35b. So the area over here is equal to 0.35b multiplied by b. So what we have is 0.35 b squared. Okay. So from here we can work out our critical stress is equal to P critical divided by A. So this will be equal to 12.5 times 10 to the power 3 divided by 0.35 b squared. Okay. So 12.5 power 3 divided by 0.35 is equal to 12.5 power 3 divided by 0.35 is equal to 35.714 times 10 to the power 3 over b squared. Okay. Then from here, we are going to equate it to our critical load. Okay, we are going to equate to our critical load. So we know that 35.714 times 10 to the power 3 over b squared. Now this will be equal to pi squared. Right, and then we have E, and then we have LE over LE. Here we have our LE over R, and then the whole thing squared. So now the dilemma comes is which LE, okay, it comes to which LE over R to use, right? So we have two expressions. If we look at our LE over R ratios, or our LE over R, right? So we can either use the 0.7 A over square root 12, okay? So we can either use this term over here, right? Or we can use this term over here. Excuse me, I beg your pardon. So what I will use the 2L over B over square root 12, because on our left-hand side over here, there's already a what? A B squared. Okay, so we're going to use, LE, or not use, we're going to substitute LE over R, which is equal to 2L over B squared root 12. L over B, right? Hold on. 2L over B, and this is square root 12. So if I were to rewrite this is equal to 2L square root 12 divided by B. Okay. As I say, why I choose this relationship over here, right? Why I choose this relationship over here? Because on the left hand side is 35.714 times 10 to the power 3 B squared. So if I use A, I have one equation, two unknowns. If I use B, I will have one unknown, one equation, which is more solvable. Okay. So from here, we have 35 0.714 times 10 to the power 3 over b squared, and this is equal to pi squared. We know our Young's modulus, 10.1 times 10 to the power wait, I can't remember now, 10 to the power 6, right? And then our LE over R, so this will be equal to 2 multiplied by L, our length is 20. Then we have square root 12. And then over here, we have a B and the whole thing squared. Okay. So just to tidy things up. So this is equal to 35.714 times 10 to the power 3. This is B squared. And over here, this would be equal to pi squared times 10.1 power 6 divided by bracket 2 times by 20 times by square root 12 close bracket, the whole thing squared is equal to 51.918. I think I pressed something wrong, so pi squared times by 10.1 power 6 divided by bracket 2 times 20 times by square root 12 close bracket, the whole thing squared is equal to 5.1918 times 10 to the power 3 b squared. Okay, so B4 will be equal to 35.714 power 3 divided by 5.1918 power 3 is equal to 6.87879, and then B you just square root twice is 1.619. Okay, it's 1.619 inches. So when that's the case, we know that A is equal, that we have a relationship A is equal to 0.35 B. So this is equal to 0.35 multiplied by 1.619, and this is 0.35 is equal to 0.567. Okay, so now there's another way, not another way of solving it, but if you were to decide, okay, so this solution procedure we use, A is equal to 0.35 B. Okay, but you can also use, okay, you can also use B. Okay, the next one, again, I'm going to put side by side, but the solution will be absolutely the same, rather than when we are using A is equal to 0.35 B. If we were to use B is equal to A divided by 0.35. Okay, so now we are going to use 1 divided by 0.35 is equal to 2.857. 2.857. So we are going to apply 2.857A. So what if now we were to use this relationship? Okay, so when we calculate our stress critical, so from here, our area will be equal to A times B, and this will be equal to A multiplied by 2.857A, and this will be equal to 2.857A squared. Right now we have this 2.8. So our stress critical is equal to our load, which is 12.5. I'll write down the formula, our critical load divided by our area. So this will be equal to 12.5 times 10 to the power 3. Now our area is 2.857 A squared. Okay. So 12.5 power 3 divided by 2.857 is equal to 44.375 times 10 to the power 3, and this will be over A squared. Okay. So again, we now have this relationship, which is equal to 4.375 times 10 to the power 3, and then we have this whole thing over A squared, and then this will equal to be pi squared E, right? LE over R squared. Okay, so we're going to substitute LE over R to be equal. So now on the left hand side, this term is having a term A squared. Okay, so we're going to substitute LE over R that has a term. Okay, so LE over R having a term. Okay, so let's go up here. Is equal to 0.5 L divided by A square root 2. Okay, so 0.5. So this will be equal to, is it 0. Sorry, it's not 0.5. Why do I say 0.5? It's equal to 0.7 L. Okay, so this is equal to 0.7 L over A divided by square root 12. Am I right? I have to confirm. A over square root 12. This is correct. Okay. So now we have the term now, which is 4.375 times 10 to the power 3 times 10 to the power 3 over A squared. Okay, and this will be equal to pi squared 10.1 times 10 to the power 6 divide by LE over R. So this will be equal to 0.7 multiplied by L. Our L, I think, is 20. And then this is square root 12. Then the whole thing over here over A, and the whole thing squared. Okay. So if I were to tidy things up, so this will be 4.375 times 10 to the power 3 over A squared, and this will be equal to pi squared times 10.1 power 6 divided by 0.7 times 20 times by square root 12 squared the whole thing. I will have 42.382 times 10 to the power 3 A squared. Okay, so I'm going to have the expression of A4 is equal to 4.375 power 3 divided by 4.375 power 3 divided by 2.382 power 3. I will get 0.1032. So A squared once, squared twice is equal to 0.567. Okay, 0.567 inch, right? And then we know that B is equal to A divided by 0.35, right? So 0.567 divided by 0.35 is 1.619. Okay, so 0.567, 1.62. Okay, which is totally exactly the same. So if you look at these two answers over here, B equals 0.169. This is 0.2. A is equal to 0.567. 0.56 is exactly the same. Okay. A very interesting problem. Okay. But not impossible. Okay. I'll come back again and we will do another example.